I'm going to leave this screen up for a while just so you can take my contact information down in my email. In case we don't have time to answer the questions tonight and you have a question in the future, within 24 hours, I do a lot of traveling. I promise I'll get back to you. So the email is a very important thing to take down. Just to give you a brief background about myself, I've started my mechanics career in the U.S. Navy in 1979. And after active duty, I've got out, went to work for a company called Air Quality Sales and also aviation battery shops. And then I had missed the military and the camaraderie, so I went back into the Air National Guard for another 16 years, with a total of 22 years military, and I still miss it today. So I learned a lot in there, and I met a lot of good people. One thing I'm still doing is speaking with retirees and veterans who want to come into the aviation business, and I'm constantly helping them and gearing them over to mechanic schools or pilot training or FAA towers, etc. So selfishly, I'm pushing aviation through the contacts I have in the military. And I worked for SAF Batteries, who is a competitor of ours that make nickel cadmium batteries. So I've spent a numerous amount of time there. Then I saw the light and found Concorde, sealed lead acid maintenance free battery, and went over to this company, and they've been good ever since. And we're constantly doing virtual IAs, and we're constantly doing in-person IAs, and our team's traveling around the country. So we enjoy doing that. We enjoy training. I did have a little bit of a lithium-ion battery training with SAFT America as well when they came out with the battery for the A380, which eventually was replaced by NiCads as well. So now that everybody took my contact information, I'll go over to the next slide. Okay, so our agenda today, we'll talk about the introduction and the history, battery technologies, lead acid batteries, battery safety, servicing and charging a battery, cleaning a battery, installation eligibility, and optimized battery life. I saw a couple of battery minder questions there, and I'll get to it a little later on in the program here. And again, if you do have additional questions, feel free to email me anytime. But the company was founded in 1977, so over 45 years of experience manufacturing certified batteries. Concorde obtained its first government qualified military spec in 79. Then they came out with the first FAA PMA approval on the wet cell batteries in 1981. Concorde was the first battery company to conditionally qualify the sealed 85, 65, 5-1, 5-2 for the government under government mil spec. And Concorde, first FAA PMA for a sealed recombinant gas. And I'll explain what that means as we go on with the program as well. In 1987, every one of our batteries now are sealed AGM, which is recombinant gas, AGM material. We have a second facility, facility in Austell, Georgia, which was opened up in 2015. We grew out of our corporate location and are still growing out of there. So we kind of shifted some of our workforce and expertise over to Austell, Georgia. So we're basically covering the U.S. East Coast, West Coast situation there. So we're constantly available for our distributors who call us, who we work with very closely. Our global distribution network is very active, and they're ordering more and more, and they're selling batteries to you, and they're keeping them fully charged, which per their requirement, they need to do that and keep those on the shelf fully charged, and every 3 months stop charge them. This is our CMM, it's our component maintenance manual. And everything is available online through concordbattery.com. Everything as far as technical bullet things go as well, or CMMs or ICAs or STCs. Everything's online, so our website has a lot of information and useful information. There is a TB15 to bring it up on battery charging. That specifically goes into maintenance charging of the battery and what to do and what not to do. So TB15 is a good source of information, and there's a lot of other TBs on there, technical bulletins, which break down the CMM. So I would definitely, if you have a moment, please take a look at that website. Also on that website, every January, we have a free of charge virtual IA for three segments of the market: piston, turbine, and rotorcraft. The piston is sponsored by AOPA. The turbine section of that is sponsored by the MBAA, and the rotorcraft is sponsored by HAI or VAI now they're calling it. So there are some great speakers that come to that approved Concorde IA series virtual IA. The FAA is monitoring it as well, so they issue certificates. And so going to our website, you can sign up probably around the October time for the January session that takes place. But again, our website has a lot of great information, a lot of useful information, CMM downloadable, and technical bulletins are very important. So I would definitely visit that if you have a moment. Okay, we're going to talk about batteries. The known technologies today, electrochemistries, are lead acid, nickel cadmium, and lithium ion is entering the world now of batteries. Okay, so that is a picture of our sealed recombinant gas AGM absorbed glass mat battery. That's a nickel cadmium battery. And when I worked on that battery and I taught my technicians, I wanted them to treat that battery as 20 individual batteries within a can. Each cell has to be monitored. You have to take readings of each cell on discharge and charge. Add the right amount of distilled or deionized water, not tap water. Tap water will destroy the electrochemistry. So there's a lot of maintenance that's involved with a nickel cadmium, and I won't take much of your time because that's another 8 hours worth of discussion. So I just wanted to bring that point up to you. That is a picture of a lithium ion battery that was installed in a 787. Together, it worked with an integrated system to supply electric power where it's needed on the aircraft. So that is a picture of a very expensive lithium-ion battery, and I believe the manufacturer is EASA. Okay, lithium-ion advantages. Obviously, you heard that more energy superior to the existing electrochemistry out there today. Weight savings, usually one-third the weight of a NiCad and a lead acid battery. So it's a very light battery. Now, the concerns is you have to have the proper and the right protection and monitoring system. I would want to know what each cell in that lithium ion battery is doing. If it's overheating, overcharging, it's not charging, it's gassing, etc. So having the right BMS, battery monitoring system, is very important. Expensive, usually the cost is the weight saving is large, but the cost is three times as much, twice to three times as much. The lifespan of a lithium ion battery really undefined at this point because no one's it hasn't been in the market for that long. And I would say if you're getting 5 to 7, 8 years out of a NiCad or other electrochemistry or a lead acid battery, you're still getting the same out of a lithium ion. So the lifespan is not defined yet, but it's been lasting as long as the other electrochemistries. There's a lot of shipping constraints when you ship lithium ion batteries. A lot of hazmat fees you're going to incur as well. Also, disposal. You just can't throw it in the dumpster in a garbage can. You have to have a hazmat specialist remove that lithium-ion battery and nickel-cadmium battery. So there's hazmat fees involved with that. Then you ask yourself, is the industry ready? Um, and that's, the manufacturers of lithium ion are pushing to get approvals there. And it's not about say only saving weight. It's about having the right equipment to service these batteries. By law, you cannot send a lithium ion battery fully charged or discharged. You have to send it out 30% charged by law. That's a DOT requirement, 30%. So at that point, you have to have the training, you have to have the right equipment to service lithium ion, and and more importantly, the training is important, and the right equipment important, and you got to be able to have the right electrochemistry for the right job. Okay, I like to break this down by first, second, and third generation. The flooded batteries, first generation, consume water through electrolysis. Water must be replenished constantly because the battery's charging and discharging. So the wet cell batteries, the flooded batteries, are losing water and they have to be replenished. Then the industry came out with what was called gel, also referred to as immobilized electrolyte, like a jelly type material. You turn that upside down and nothing will come out of the battery. It was like jelly, hard jelly. But there was a void in gel, the passing of the electrodes to charge and discharge and make capacity check was difficult and very hard to achieve. So gel came and gone very quickly. We introduced the sealed recombinant gas, also known as absorbed glass mat, valve regulated sealed lead acid battery. So a third generation of the battery is recombinant gas. That means the gas doesn't escape out of the battery. It recombines itself on the AGM material. The AGM material is 99% absorbent of the electrolyte. So we put enough electrolyte in there into the AGM material to last the life of the battery. Valve regulated battery, we have a valve regulated that goes off at 1 psi and it's recombined on the AGM material. So you're never losing any water out of that battery, and you don't have to service that battery. You can't remove the top, otherwise you void the warranty. Now, these pictures on the bottom there are cell jars. Basically, the one to the left there has cells and AGM material going all the way down to the bottom of the cell can. And at that point, the second one, yeah, you'll see a little bit of the space. I hope everyone could see this on the bottom of that battery cell jar, due to the fact that electrolyte needs to be absorbed into that area. So usually 30 to 40 minutes to absorb the electrolyte level and absorb to the bottom of that can. The third item next to that is gel, and that item there, like I said, it came and gone very quickly, you know. We no longer have that. But the good thing about the one on the left, which is a carbonate gas, lead acid battery, all the plates are larger. And what that gives you is more capacity, believe it or not. You have larger plates, you have combined plates together in there. You don't have to have any space for absorbent electrolyte. Like I said, the AGM material is 99% absorbent, so we put enough in there to last the life of the battery. This is a cutaway of a recombinant gas valve regulated battery. You can see the white material being the AGM. The positive and negative plates are coated with a protective coating. There's a block of lead that puts the positive and negative plates together, keeps them together. And this battery was 100% handmade by third generation families, believe it or not, in the factory. And I think the only point that me, Dave Schiavone, has to say about handmade products is that, our competitor has built batteries on robots, on spot welding and things like that. And through vibration, we've also known that, spot welding breaks and cracks and the battery doesn't last as long. So having the batteries handmade and checked is very important. Now, also, Concorde's the only battery company that every battery, not by lots, we manufacture it from zero, from scratch. We charge that battery up and we do a capacity check to see if it makes capacity. Once that happens, we charge the battery up, or we do a second capacity check, and charge that back up. We put it in the box. We send it out to a distributor. They're responsible per distribution contract to keep that battery fully charged. And the only responsibility that the customer has when they get that battery is to do a open circuit voltage check. That means, is the battery fully charged? If it's a 24-volt battery, you've got to see 25.8. So rest assured that that battery's coming to you fully charged. If it's not, top it. Through heat and storage, it can lose some capacity, but you install that battery when it's fully charged in the aircraft. A year later, you do a capacity check. You pull it, you do a capacity check. Depending on how it performs, is when you do your other interval of a capacity check. Copper terminals. We use copper terminals for improvement of high rate discharge, efficient for engine starting as well. The terminal connector there is a nickel coated copper. What I would say about that main connector area is make sure that there's no cracks in there when you first receive the battery. Make sure that that nickel coated copper is intact on those terminal plugs. If it's not, you could possibly have a problem with connectivity. What I tell mechanics, what I train mechanics is don't take the aircraft Elcon side and slap that on the battery, because once you do that, you crack the receptacle and you uh, ruin the terminal plug as well. Okay. Okay. So I've mentioned the interconnection connectors, the big block of lead on top, bringing the positive and negative plates together. Electrodes, quality surface area determines the battery capacity. They're down to the bottom of the can. They're compressed in there as much as possible. They give you as much capacity as possible. Okay. Temperature versus power. What is IPP? Initial peak power, current peak rating is basically like a coal cranking amps, and we test that 15-second power rating under those temperatures. So think cold cranking amps, and you usually see this in ground power starting equipment, those specifications. So that would be helpful. So again, battery safety, refer to our Bible, which is our CMM there. Um, you see out in the field, you see AMMs, and they incorporate a lot of safety techniques that are in the safe important notes that are in the CMM. So available on ConcordeBattery.com, proper lifting techniques, shocks, hazards, et cetera, how to basically wear eye protection, et cetera, especially if you're working on other electrochemistries. There's a chance of getting electrolyte on your body. Okay, true or false? You should store batteries on the ground. Okay, a misnomer. When the batteries first came out, they were a hard rubber material, and they said not to store it because it could lose capacity. They also, you see a picture of a shorted clip. Never do this. This will completely sulfate the battery. Might as well just use it as a boat anchor at this point. You want to do this on a nickel cadmium battery because the electrochemistry of those cells, if you don't strap them off and tie the receptacle up, they could possibly go in reverse. So you don't want those cells to be negative 1.2 volts, etc. So on a lead acid battery, you keep it fully charged at all times. On a nickel cadmium battery, you keep it discharged. Okay, Concorde batteries, valve-regulated batteries may be serviced in any battery facility, including nickel-cadmium battery facility. Valve-regulated batteries are sealed to prevent cross-contamination. Now, they used to say you have to have two shops, one for lead acid and one for NiCad. So the case is, if you're working on a Concorde battery and it's a sealed battery, there's no chance of cross-contamination to the NiCad or wet battery cells. So you can work on that in the same shop. Okay, what is required to commission a flooded dry charge battery and valve regulated battery? So all our batteries as of 2013 have all gone over to AGM, absorbed glass mat. Each battery is capacity test more than once, twice in the factory before it's sent out to a distributor. Uh, and the minimum 100% capacity requirement to perform being released for shipment. So we want to make sure that you have a good product going to you, and our distributors are constantly being told that they need to go out there and buy some type of battery charging equipment, battery minder, BC 8000, BC 9000, whatever they have, just to keep the battery fully charged when the battery voltage drops. And that's the way you check the battery, whether if it's not active and it's sitting on a shelf or it's not in your airplane that's not flying, you have to check your OCV. Once your OCV, your open circuit voltage falls, you boost charge that battery and keep it fully charged. Also, when I say fully charged, I mean desulfated as well. Once you remove a battery, any battery, even a car battery, off of a battery charge, it will start sulfating. That white crystal material on the positive and negative plates, which makes it harder to charge. So you want to make sure that the battery is desulfated. And we'll go into charging equipment in a little bit. But on a dry battery, just a chart made up here, you fill the battery with electrolyte. You let it soak time for 30 minutes to an hour. You check the electrolyte level and add electrolyte level to the correct position, just slightly above the plates. Charge the battery for 1 hour, recheck electrolyte level, remove or add electrolyte as needed. Charge until specific gravity stabilizes approximately 8 to 12 hours. Adjust the electrolyte level with the charger on. Make sure that, again, that it's at the right level. You perform a capacity check to assure that the battery has been adequately activated. Okay, recharge the battery, wash and dry it. These are wet batteries. You wash and dry it, make a mess. Be, so to bring a point to you, just because you received a brand new battery, wet battery in a box, and then you receive the electrolyte, you pour the electrolyte in, you have to do a capacity check to see if the battery is airworthy. Battery is not airworthy unless you do a capacity check. Battery has to pass. Any battery out there has to have a capacity check to be airworthy. So the middle column is you check your open circuit voltage, specific battery on 12-volt battery, 12.75, it's in the CMM, and 25.5, 25.8 is fully charged on a 24-volt battery. OCV equals to exceeds, etc. You install it, and a year later, you do a first capacity check. Third column, NiCad, for any NiCad users out there. You remove the lid, you clean your battery, you clean any widget before you work on it. I wouldn't want to work on a dirty battery, and you torque that battery because a vibration will loosen the screws. And believe it or not, there's a lower nut torque in the NiCad CMM that says that that has to be properly torqued as well because it could cause capacity problems if it's not torqued correctly. The each link is nickel coated copper. Again, if you see copper, make a note, annotate, uh, annotate it that you need to replace the hardware you're seeing copper. Again, connectivity problems in the future. So you adjust the electrolyte level with the charger on, verify end of charge voltage of each cell. Now, again, you have to record each cell 1.50 on charge, etc. On discharge. Each volt has to be 1 volt or above. So you make sure that's recorded. Also, what's not here is to record the amount of distilled or deionized water you put in each cell. Because if you have a cell, say it's number 7 cell in a NiCad battery, and it's using more than usual water, that material internally of that cell is burning up and breaking down. And that's what causes you to change cells, the breakdown of the separating material. So you want to record how much water each cell is taking. You do an insulation check, usually screw to the side just in case you have any electrolyte that could fall underneath the cells, etc. Because if you have electrolyte there, it will discharge slowly and lose capacity in that battery. Okay, servicing and charging. Always refer to the ICA, your CMM, owner's operator manual, and again, available on the Concorde Battery website. A lot of customers are using AMMs now. The AMM will supersede the CMM, Aircraft Maintenance Manual. So I have a lot of questions regarding that. A engineer may put together a AMM that requires a interval of capacity check at a certain time. So follow your AMM if you have one. Activities consist of checking your open circuit voltage, charging the battery, doing a capacity check on the battery to determine airworthiness. If it fails a capacity check and you follow your CMM, there is a procedure in the CMM called the conditioning charge. Conditioning charge is a longer charge at a lower capacity for 16 hours. You can break that up and do 8 one day and 8 the other day. We'll go over that in a little bit, but that completely cleans the plates for you to be able to do a second capacity check. You're allowed per the CMM 3 capacity checks. Okay, see, you have a picture here of a 24-volt battery. You have your meter. Your meter shows that battery is fully charged, 25.8. I hope everybody can see that. We put a load on that battery in the factory and it failed miserably because some of those plates were working harder to give that voltage and some were severely sulfated. So unless you do a bench capacity check, you don't know whether or not you have an airworthy battery. And it's very important to get that capacity check done as well. Put a load on the battery to see if that voltage holds. Okay, so on the 12-volt battery, if it comes to you and you check your open circuit voltage and it's 12.6, 12.3, you're only at 75%, 50%. Those of you who have 24-volt batteries, if a distributor sends it to you and it's at 24.6, it's only 50%. So the OCV is not fully charged. You can look at the 100% charge of the 12 volt versus the 24 volt OCV. So state of charge is not state of health. Don't get them confused. Make sure that you check that OCV. Okay, these are the chart. We have no skin in the game. Our engineers go out to these charging manufacturers and we recommend, and we endorse these chargers. Now, the one that is a very good tool, and I'm going to pick out the battery minder, one for 12 and one for 24 volt, but it is a temperature sensor control battery minder, and desulfator. There's a light that's constantly blinking when the battery light comes on. It says, I'm fully charged, but you're going to still have a yellow blinking light that says, hey, I'm looking for sulfation. I know the battery is not active but I'm looking for sulfation. If I see sulfation, I'm going to zap it out. Now, a lot of people come up to me recently at Sun and Fun and Oshkosh. I'm going to have this question. If I get a dime every time someone asks me, should I keep it on all the time? I would be a millionaire and could retire. So the question is, if your aircraft's not active, your battery's not active, I would put it on there. So to stop the sulfating process. And I would just come by 2 weeks, a month later, whatever, check your OCV and remove it. You don't need to keep it on all the time. Will it kill it? Maybe 5 years, 6 years, it might dry out the AGM material and the plates. So keeping it on for 5, 6 years, will eventually do that. It's not going to hurt it if you keep it on all the time. But in a long period of time, that could happen. Again, Technical Bulletin 15 explains this in detail. So again, my recommendation is if you're not active, if you're not flying, if you're going to store the airplane, keep the battery minder on there and keep it fully charged. Check the OCV. The OCV is good. Remove it. Put it back on in another 2, 3 weeks. But again, it's a good unit. It's always looking for sulfation and it keeps the battery fully charged. The other units are available. Very popular item. There may be a lead time on them, but there's a discharger, charger, and one that's a combination, which is the BC8000. The BC8000 is a charger and discharger. What I like about that unit, especially for someone with a battery shop, you could put a thumb drive on that in the back of that thing and print out discharge curves. And I used to keep them with my work order of how the battery performance did. And you can work on nickel cadmium and lead acid batteries as well with that unit. So that's a BC8000. We do endorse another charger that's on our website. I don't have a picture of it here, but it's duly listed, and it's called ATEQ, ATEQ. You can see that available on our website. Now, they're not a combination unit, they're separate. You have to buy a charger and you have to buy an analyzer. But that's available on our picture of that, and details are available on our website. Okay, so what time should an inactive lead acid battery be boost charged to prevent it from sulfating? And the answer is C, anytime the voltage falls. I know I said 3 months, but our distributors understand that. So anytime the voltage falls, so you're always checking the OCV to extend the battery life. Discharge rates. Okay. Flooded battery discharge rates. Okay, those are every 30 days under different temperatures. Um, you can see the difference there between a wet cell battery and a RG AGM battery. Okay. Is it okay to fast charge a lead acid battery? It absolutely is okay to fast charge it. For those of you who are using NiCads, that's a different situation. Uh, the manual will specify what can be reflex charged and what can be um, accept the higher voltage. The cells are electrochemistry different. So with a lead acid battery, you can fast charge it. Servicing and charging RG series batteries can accept charging rates up to 8 times the C rate, page 107 of the CMM. Is a fast charge the best charging procedure for a lead acid battery? You must control the voltage. That's the important thing. So you have to keep that in mind. Okay, airworthiness, capacity testing, minimum capacity testing for airworthiness. What is the minimum lead acid capacity, battery capacity for airworthiness according to the FAA? They say 80%. What is the FAA recommended requirement to return to service? They say 85% of capacity. What is Concorde's minimum battery capacity requirement to return to service? 85%. And I'll go into that a little bit. 85% is 15 minutes of the C1 rate. I'll explain that in a minute. Servicing and charging, these are our manuals that are available and downloadable on the website. Okay, a capacity test is the only way to determine airworthiness. This is a reading off of a BC 8000. This is what the information board in front of the unit will say. Battery, it's automatically programmed that the battery passed. The C1 rate was 105%. The end service was 20 volts. Okay, so fully charge the battery when it comes into your battery shop, battery area. Discharge the battery at the C1 rate, endpoint voltage of 20. Okay, after 51 minutes, it's 85%. Check the battery voltage. So again, it has to be 20 volts for a 24 volt battery, 10 volts after capacity for a 12-volt battery. And you're doing it for C1. You're doing it at the C1 rate, which is one time the capacity. So, for instance, if it's a 25 ampere hour battery, 25 is C1, 40 is C1. So again, 51 minutes of a load of the C1 rate. So at 25 per minute, let's take 51 minutes, you're getting 85% capacity. And the battery has to be 20 volts or 10 volts in 51 minutes. Again, this is all spelled out in technical bulletins as well as the CMM and actually a lot, even myself, I go back to the CMM all the time. I'm reading it when I have nothing to do. And I'm always training students to read the CMM. In fact, I don't even show them this PowerPoint. I take a CMM with me and I ask them, tell me what page and explain to me what consists of a capacity check. What do you do? What's the procedure you do if it fails a capacity check? And we work off that CMM. So I think that, having reminding people that it exists and everything you need to know is in black and white, either in the CMM or AMM or OMM. So anyway, 54%, 54 minutes is 90% capacity. Technical bulletin number 14 explains capacity check intervals. Again, please look at technical bulletin 14. If you're unsure about, okay, after a year, my battery passed, when do I do my next capacity check? Depends on performance. It depends on what the AMM says. So it depends on a lot of factors, but TB14 explains the scenario in full. So again, if you're looking for battery maintenance on battery minders, TB15, interval battery capacity checks are TB14. Oh, technical bulletin 14, capacity check intervals. Sorry to repeat myself. So anyway, our CMM specifies everything. Okay. This is what sulfation looks like on a under a microscope. Thank you. Can't get that out. But if you have that new spongy plate, it's going to be very hard to capture charge and discharge for that matter. And the battery is going to fail. So it's important to keep it fully charged, keep it fully desulfated when you keep it fully charged. Okay, sulfation is caused by leaving a battery discharged for a long time before recharging it. You do a cap check, you let it cool for a minute, and you charge it right up immediately. If you leave it discharged, it'll keep desulfating and to the point where it may not be recoverable after a while. Just like someone leaves the switch on, it drains the battery, it desulfates the battery. It may not be able to be recoverable. Repetitive undercharging, short legs, many starts per day. If you're going for flying for an hour and a half, it's not enough to fully charge the battery. So at that point, if you're doing short hops, it's important to put a battery minder on there when it comes back to the hangar. And if it's not getting a full charged battery, also could cause sulfation problems. So again, not flying, long, short leg, put a battery reminder on there. Parasitic load. A parasitic load, it's funny because I'm always telling people that this could be a parasitic load, could be a clock, a new piece of avionics, someone leaving the door light on, someone not shutting the door, and if a light stays on, it'll drain the battery. On my when I talk to corporates, I tell them if you can, when the aircraft comes back in the hangar and then you have a 24-volt battery, remove the Elcon from the battery, just in case of a parasitic load. So, so it's there's a lot of parasitic load scenarios, but to summarize this is make sure you keep the battery fully charged at all time, and make sure it gets a full charge. Avoid parasitic loads, extended doormat periods. The longer these conditions persist, the harder it is to reverse. If the plates are heavily sulfated, the battery may not be recoverable and must be scrapped. And you're allowed to do a conditioning charge and do another capacity check. But running a shop, running an FAA 145 repair station, honestly, 16 hours to do I would tell the customer, do you want me to go that extra step, Mr. Customer? The battery age is X, and if it was more than 5 years old, I would recommend them buying a new battery. And they would ask me, well, what's the lifespan of a battery? And I always have to quote the what's in the CMM. And we recommend 4 years, 5 years, uh, replace your battery. People don't do a capacity check. They just replace the battery because it's still an inexpensive item. So they just replace the battery every 4 or 5 years anyway. So that's an option that Mr. Customer has, and they can do that as well. Cures full sulfation, charge the battery soon after it is discharged, eliminate any parasitic loads, use a battery maintainer, desulfator if charge time on aircraft is too short, use a low constant rate conditioning charge. When you do a conditioning charge, you should do constant current charge again for 16 hours. 8 and 8 is fine. You can break that up. When you charge the battery, it's recommended per the CMM to do a regular charge on the battery. Conditioning. What can be done to correct lead acid batteries that are sulfated due to inactivity, over discharge, or will not accept a charge, conditioning charge that fails a capacity check. Okay, we'll go into this a little bit. Conditioning charge procedure. Discharge the battery. Charge using constant current for 16 hours. Again, you could do 8 and 8. Uh, After charging, allow the battery to cool, then do a capacity check. And it is not airworthy with a dead battery. You can't jump start that battery. Uh, you can't, it's not airworthy if you jump start it because if you need electrical power failure and you need capacity, you're going down very quickly, unfortunately. So you have to make sure that it's capacity checked. Usually takes about three and a half, 4 hours to fully charge a battery. So, okay. So the discharge minimums, what is the minimum level voltage a lead acid battery can be discharged before it's damaged? The answer is C, 9 volts for 12 and 18 volts for 24. So if someone drops a battery and it cracks like that, you might as well drop it again in the garbage pail because you could have a loss of electrolyte. Uh, Shock could ruin the positive and negative plates, and you could have a lot of problems. So there's no fix there. It's a condemned battery. Okay, concave bulging is normal. Usually see that through charging and discharging, but in 24 to 48 hours, it usually goes back to the position. And this goes with other electrochemistries as well. Batteries bulge, and as long as the battery performs electrically, and what I mean by that, if it's capable of taking a charge and it meets capacity check, then it meets electrically passes. So don't worry about bulging. It's a hard PVC type material, fireproof, so you're good there. Be careful when um, you're torquing here. The batteries could crack. So yeah, technical bulletin number 11 discusses connector maintenance, how to clean them, what the torque value is there. Anything over 70 inch pounds may crack the epoxy there. So you have to be very careful with that. Okay. Best way to clean the battery. Okay. Water, lint-free cloth and tap water is all you need. There's no chance of water getting in the battery. Um, so all you need is lint-free cloth and water. Okay. Eligibility, installation eligibility, Concorde battery eligibility list available on our website. If you have any questions, our customer service department has, more than 50 years, 45 years experience, and usually it's a live voice when you call, and they have a lot. The team itself has over 100 years of battery experience combined, so we're there to answer the phone, to help you out, to answer your questions, to provide you with training. Like I said, you'll probably see us at some in-person IAs if you're planning on attending that. But we're constantly traveling around the country, and I have Canada as well, so I cover Canada and train the AMEs up that way. Okay, voltage regulator settings. This is recommendation out of the ICA for voltage regulator settings. So it's not set correctly obviously, it will heat the battery up. And so you want to make sure that this is in the OMM, which is available on the website. You can download the OMM as well. Um, but I'll leave this up here, and you're some people change their voltage regulator setting in the winter and the summer if they fall under this parameters. Okay, parasitic load tester for a 24-volt battery. This is something that our distributors have that we manufacture in case you want to check for a parasitic load. You put it on the battery and you put the L-con to it and put your leads, attach your leads, and do a voltage check from there. Parasitic load tester. Keep it fully charged. Do not overcharge it. Avoid any parasitic loads. Parasitic load part number is 4102. Summary. Open circuit voltage does not equal state of health. The only way you're going to find state of health is to do a capacity check. So, Dave, I got a full battery. It's been 8 years, and I use a battery minder, and it's a wonderful product. But have you done a capacity check? Well, some people have said to me, "What's a capacity check?" I just buy a battery and every 8 years. And then the next question is, how come the price tag is going up so much? Well, price of lead, you know, has gone up, and price of material has gone up, etc. You've got more than 5 years on the battery. It paid for itself, believe me. So again, summarize, open circuit voltage doesn't mean state of health. The only way to do state health is to do a capacity check. Capacity check is the only way to determine airworthiness. Don't jump start your battery. Never do that. It's not airworthy. Keep it charged without overcharging it.